So today in this class, we will mostly try to cover conic section. Circles I have already covered in a previous session. So I'm not going to do that once again. So what we are going to do is parabola. We'll also try to get over with ellipse and hyperbola. As far the NCERT is concerned, parabola, ellipse and hyperbola are at a very basic scale in the school syllabus. Alright. So today we will also try to cover with parabola with its tangent and its normals. Fine. So first of all, what is parabola? Parabola is the locus of a point which moves in a plane in such a way that its distance from a fixed point, to which we call its focus, its distance from a fixed point is equal to its perpendicular distance from a fixed line. So, locus of a point which is moving in such a way in a plane that its distance from a fixed point, this PS, is equals to its distance from a fixed line, that is, that is PM. So, PS is equals to PM. So, from this, we derive the equation of a standard parabola. If I take fixed point as a comma 0, fixed point as a comma 0, and fixed line as x equals to minus a. Understood? So you can see distance of PS will be what? X minus a square plus y square under root is equals to distance from the line x plus a equals to 0, that is x plus a. Now if you square both the sides and simplify, you will get y square equals to 4ax. This is the equation of standard right opening parabola. Equation of standard right opening parabola. Now let's understand some terminologies about it. See, axis. The straight line passing through the focus and perpendicular to the directrix is called axis of the conic. This is called the axis of the conic. This is also the axis of symmetry. And in a standard parabola, y square equals to 4ax. This axis of symmetry is what we call x-axis. Got it? And this is also called major axis in ellipse and transverse axis in hyperbola. So a straight line which passes through the focus and perpendicular to the directrix is called the axis of the conic or axis of symmetry of the parabola. Now vertex, the point of intersection of conic section with the axis is called vertex or vertices of the conic. This is for across the parabola, ellipse, hyperbola, everywhere. Points where axis of symmetry intersects the conic is called vertex of the conic. Now focal chord. Any chord which passes through the focus is called focal chord of the conic. Any chord which passes through the focus is called focal chord of the conic. Double ordinate. Now any chord drawn perpendicular to the axis is a double ordinate of the conic section. Any chord which is perpendicular to the axis is called double ordinate of the conic section. And now very important term, latus rectum. Double ordinate which passes through the focus is called latus rectum. Now see here from this one diagram, any chord which is passing through the focus is what we call focal chord. Got it? Now, any chord which is perpendicular to the axis is what we call double ordinate. Double ordinate. And double ordinate which is passing through the focus or focal chord which is perpendicular to the axis, that is what we call latus rectum. Latus rectum. Got it? Now, for all the four standard parabolas, one is y square equals to 4ax, y square equals to minus 4ax, x square equals to 4ay, and x square equals to minus 4ay. There in this slide, you see all the parameters like vertex everywhere is 0, 0. The diagrams I will also draw for you. Y square equal to 4ax is like this. This is y square equals to 4ax. If it is left opening, then this is y square equals to minus 4x. I'm assuming a is positive. If it is upward opening, this is x square equals to 4ay. And if it is downward opening, it is x square equals to minus 4ay. Got it? So in y square equal to 4ax, focus is a comma 0. Directrix is x equals to minus a. Equation of axis is x-axis, that is y equal to 0. Latus rectum is 4a. Focal distance of any point means distance of any point from the focus is what? You don't have to use the distance formula. That is equal to the distance from the directrix. And distance from the directrix is a plus x. And parametric coordinate will be 80 square to 80. Parametric equation of the parabola will be 80 square comma 2at. Understood? Now when it comes to y square equal to minus 4ax, focus will be minus a comma 0. Rest everything is almost same. Similarly, you can analyze things for x square equals to 4ay and x square equals to minus 4ay. Now, position of a point with respect to a parabola. The point x1, y1 will lie inside, on or outside the parabola if y1 square minus 4ax1, y1 square minus 4ax1, it is less than 0 or it is equal to 0 or it is more than 0. So if it is less than 0, it lies inside the parabola. If it is equal to 0, it lies on the parabola. And if it is more than 0, it lies outside the parabola. Understood? So this is how we judge about the point lying inside the parabola or outside the parabola. Now there we go with the condition for tangency. See, in the slope form, tangent will be y equals to mx plus a upon m. Got it? Definitely m should not be 0. So in the slope form, tangent is y equals to mx plus a by m. And in that case, point of contact is a upon m square comma 2a upon m. Point of contact is a upon m square 2a upon m. Now comparing this point with the parametric condition of the point on the parabola, we get t equals to 1 by m. Leave this point. Now equation of tangent in point form. So how do we get the tangents in point form? We replace x square by xx1, y square upon yy1, x we replace by x plus x1 upon 2, y we replace by y plus y1 upon 2, and constant we leave as it is. If there is a term of xy also, we replace by xy1 plus yx1 upon 2. xy1 plus yx1 upon 2. This is very rarely used. So if I use these substitutions and this x1, y1 point is lying on the parabola or any conic, you will get the equation of tangent right at the moment. So for y square equals to 4ax, equation of tangent at x1, y1 will be y1 equals to 2a times x plus x1. If your parabola is x square equals to 4ay, then tangent at x1, y1 will be xx1 is equals to 4a times y plus y1 upon 2. Am I clear? So that is xx1 is equals to 2a times y plus y1. So equation of tangent can always be obtained in this very easy manner. You replace x square by xx1, y square by y by 1, x by x plus x1 by 2, y by y plus y1 by 2. But make sure before using this x1 by 1 point should lie on the conic. If it is outside the conic, this equation will not be a tangent anymore. This equation will be chord of contact. We'll talk about it in a while. Got it? Now, tangent in parametric form. So if this is the parabola y square equals to 4ax, now there is a point on it. Say it is 80 square 280, which is the parametric point. So equation of tangent can easily be written. Equation of tangent can easily be written like in the form of 80 square 280. Equation of tangent can easily be written like in the point form. So y into 280 is equals to 4a times x plus 80 square upon 2. Got it? So from this 2a, this 2 and this 4a totally cancelled. So it is ty is equals to x plus at square. Ty equals to x plus at square. Got it? Now see, let us assume there are 2 points. So one point was that one, there is another point at2 square 2at2. And this point is 81 square 281. Now you have drawn another tangent to it. Now this point of intersection of these tangents. This point of intersection of tangent will be a t1 t2 comma a t1 plus t2. A t1 t2 comma a t1 plus t2. How do I remember it? This is the geometric mean of x coordinates of the points A and B, and its y coordinate is the arithmetic mean of the y coordinates of A and B. X coordinate is the geometric mean of x coordinates of A and B, and y coordinate is the arithmetic mean. This is the geometric mean. This is the arithmetic mean. So now it becomes quite easier to remember. Understood? Now, equation of normal. See, simple one form is of normal is line perpendicular to tangent at the point of contact. Got it? So slope of tangent in the point form was what? 2a upon y1. Slope of tangent was 2a upon y1. So slope of normal will be minus of y1 upon 2a. So equation of normal will be y minus y1 is minus y1 upon 2a into x minus x1. That's it. So with this, we got the equation of normal. Now, equation of normal in slope form is quite an important point. See, slope form means equation in the form of slope m. So, normal in slope form is not basically perpendicular to the tangent in slope form. Normal in slope form is actually perpendicular, parallel to the tangent in slope form because they both are of same slope m. So first of all, don't get confused with this. Normal in slope form is quite a different line from tangent in slope form. So equation of normal will be y equals to mx minus 2am minus am cube. Y equals to mx minus 2am minus am cube. And its point of normal is am square minus 2am. And point where this is normal is am square minus 2am. Now equation of normal in parametric form is actually normal at the parametric point 80 square 280. So it will be it will be perpendicular to the tangent at that parametric point. So tangent what ty equals to x plus 80 square, and normal will be Tx plus y is equals to 2at plus at cube. Got it? So equation of normal in the of the parabola is Tx plus y equals to 2at plus at cube. Now, relation between T1 and T2, if normal at T1 meet the parabola again at T2. Now see, normal at T1, normal at T1 will be T1x plus y is 2at1 plus at1 cube. Normal at T1 is T1x plus y is 2at1 plus at1 cube. Now this normal meets the parabola again at T2. Again at T2 means at2 square 2at2. Now let's make this normal pass through T2. So T1 into at2 square plus 2at2 is 2at1 plus at1 cube. Got it? Now you see A cancel from all the sides. At2 square T1 cube. Relation between T1 and T2 if the normal at T1 meet the parabola again at T2. Normal at T1 is T1y, T1x plus y equals to 2at1 plus at1 cube. Now I made it pass through at2 square 2at2. Fine. So it is 2t2 is equals to 2t1 plus, yes. Now let's do one thing. Take 2 common, I get T2 minus T1 plus take T1 common, I get T2 square minus T1 square as 0. Now take T2 minus T1 common. So 2 plus T1 into T1 plus T2 goes 0. Now see, T1 is definitely not equal to T2. So this is 0. That means T1 plus T2 is minus 2 upon T1. So implies T2 is minus T1 minus 2 upon T1. T2 is minus T1 minus 2 upon T1. This is a very, very important question generally asked in the exams directly. Okay, find the relation between T1 and T2 if normal at T1 is meeting the parabola again at T2. Got it? Now, pair of tangents is SS1 equals to T square. This is also valid across all the conics. SS1 equals to T square. Got it? Now, chord of contact. Chord of contact, I told you, if this x1, y1 point lies outside the parabola. First of all, what is chord of contact? The chord joining point of contacts of two tangents drawn from an external point x1, y1 to the parabola is known as chord of contact. That means if this is a parabola, now see there is a point externally. Say this is the point P. You draw it two tangents from P to this parabola. One is this and other is this. So this is point A and say this is point B. A and B are point of contact. So this AB is called chord of contact of the parabola with respect to point P. AB is chord of contact to the parabola with respect to point P. And its equation is given as t equal to 0. Like it is, the equation of the tangent was there. And the equation of chord of contact is exactly like it was tangent. But here this point x1, y1 is outside the parabola. In case of tangent, this point x1, y1 will be lying on the parabola. Got it? So this equation t equals to 0, that is obtained by replacing x square by xx1, y square by y1, x replaced by x plus x1 by 2, y replaced by y plus y1 by 2, and c kept c. So the equation you obtained is tangent if this point x1, y1 lies on the conic, and it is chord of contact if this point x1, y1 lies outside the conic. Got it? Now, chord bisected at the point. So if there is a chord of the conic whose middle point is x1, y1, then its equation, very standard form, is t equal to s1. Got it? S1 is what? Put the point in the conic. And T is what? That substitution we use. So like for y square equals to 4ax. Equation of chord with given middle point as x1, y1. Equation of chord with a given middle point as x1, y1 will be t equals to s1. So it is y1 minus 2a times x plus x1 is y1 square minus 4ax1. This is the equation of chord with the given middle point. Now, what is a director circle? Basically, director circle is the locus of a point from which two perpendicular tangents can be drawn to the conic. All right. So director circle is the locus of a point from which two perpendicular tangents can be drawn to a conic. Like if you remember, in case of circle, director circle was a concentric circle whose radius is under root 2 times of the original circle. In case of circle, director circle is another concentric circle whose radius is under root 2 times the radius of the original circle. But in case of parabola, director circle is actually not a circle. In case of parabola, directrix is director circle. So from any point on the directrix, you will always be able to draw two perpendicular tangents to the parabola. Or if two perpendicular tangents are there for a parabola, they will meet definitely at the directrix. So for y square equals to 4ax, x plus a equal to 0 is the directrix of the parabola, which will act as the director circle. All right. Well, now let's see a question. Tangents are drawn to this parabola which is perpendicular to this line. Which of the following does not lie on it? Now see. If you would like to give it a try, take a moment. Try it for 2 minutes. I'm launching a poll. So once you attempt, mark your answer in this poll section. Yes. Give it a try quickly. Others also respond. See, tangents are drawn to this which is perpendicular to this line. So a line is given to you, you know its slope. So you must be knowing the slope of line perpendicular to this. And you know the slope, then you know the tangent y equal to mx plus a upon m. Quickly give it a try. All right, I'll do it for you. Now see, the line is given to you as 2x plus y equals to 1. So This line can be written as y equals to minus 2x plus 1. Slope of the line is minus 2. Now they are asking for the tangent perpendicular to this line. So slope of tangent should be 1 by 2, because if two lines are perpendicular, product of their slopes goes minus 1. So equation of tangent will be y equals to mx plus a upon m. If I compare this parabola with y square equals to 4ax, that means 4a is 6. So a is 3 upon 2. So what do you get? Y equals to m means 1 by 2 into x plus 3 upon 2, and here it is 1 by 2. So this 2 cancel. So it is y equals to x by 2 plus 3. Now see at from by how many points this line is passing. Is it passing through 0, comma 3? Yes. Is it passing through minus 6, comma 0? X minus 6? Yes. Is it passing through 4, comma 5? Yes. Is it passing through 5, comma 4? No. So this is your correct answer. Because they are asking the following point does not lie on it. So this y equals 5, comma 4 does not lie on this. All right. Now let's see another question. If one end of the focal chord AB of the parabola is at this, the equation of the tangent to it at B. All right. One end of the focal chord AB of the parabola is at this. Now tangents at the ends of the focal chord are perpendicular to each other. Yes or no? That's secondary deal. Another thing is, say this is the parabola. This is your parabola. If it is a focal chord, if this point is at square comma 2at, then this point is a upon t square minus 2a upon t. Got it? Means if t1, t2 are the ends of the focal chord, then t1, t2 goes minus 1. So first of all, see this parabola is y square equals to 8x. Means value of a is 2. Now parametric point will be 2t square comma 4t. Now this point is equivalent to 1 by 2 comma minus 2. That means 2t square is 1 by 2 and 4t is minus 2. So here t is plus minus half, here t is minus half. So t is actually minus. Got it? So if t is minus half, that means parameter at B. Parameter at point B will be 2 because t1, t2 is minus 1. So point B will be at square, that is 8 comma 8. Point B will be 8 comma 8. Now equation of tangent at 8 comma 8 will be 8y equals to 8 times x plus 8 upon 2. This 8 cancel. So it is x minus 2y plus 8 is equals to 0. X minus 2y plus 8 is equals to 0. So one end of the focal chord is given to you. Another end we can find very easily, and once we got the another end, equation of tangent can be written simply like in the form of point. Y1 equals to 2a times x plus x1. Understood everybody? Now, let's come to ellipse. See, ellipse is the locus of a point which is moved in such a way that the ratio of its distance from a fixed point and its distance from a fixed line. Ratio of its distance from a fixed point and from a fixed line is always constant. This constant is E. This fixed point is what we call focus. This fixed line is what we call directrix. And this constant E eccentricity, it should be less than 1. Means, say there is a point x1 comma y1. There is a line. Say the line is ax plus by plus c equal to 0. We are trying to find the locus of this point p x comma y. So ps is equals to pm. ps is equals to, sorry. So ps upon pm is e. And this is what we call locus if this eccentricity E is less than 1. If this eccentricity E goes more than 1, then your locus will be hyperbola. Now PS is what? PS is x minus x1 whole square plus y minus y1 whole square under root upon PM will be what? ax plus by plus c upon under root of a square plus b square mod is equals to E. Now you square both sides, simplify it, you get the standard equation of the, equation of the ellipse, not standard. Now, very important definition of the ellipse. Definition 2. An ellipse is the set of all the points in a plane, the sum of whose distances from two fixed points in the plane is a constant. I repeat, an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is always constant, and this constant is equal to the length of the major axis. In short, I explain you, if there is a point P, if PF1 plus PF2, PF1 plus PF2 is equals to 2A. PF1 plus PF2 is equals to 2A. 2A is what? Length of major axis. So PF1 plus PF2 is equals to 2A. That is the length of major axis. So if a point P is moving in such a way that the sum of its distance from two fixed points is always constant. Two fixed points are what? F1 and F2. That the sum of its distance from two fixed points is always constant, and this constant is greater than the distance between fixed points. If a point P is moving in such a way that the sum of its distance from two fixed points F1 and F2 is always constant, and this constant is more than the distance between fixed points, then this is the locus of this point P is what we call ellipse. Got it? Very important property. Now, if I talk about the ellipse x square by a square plus y square upon b square equals to 1, these are the facts that you are already aware of. Center is 0, 0. Vertices are a comma 0 and minus a comma 0. These are also called the ends of the major axis. Foci are c comma 0 and minus c comma 0, to which we call ae comma 0 and minus ae comma 0. Length of major axis 2a, length of minor axis 2b, equation of major axis y equal to 0, which is x-axis, equation of minor axis x equal to 0, which is y-axis, and eccentricity E is under root of 1 minus b square upon a square. E is under root of 1 minus b square upon a square. Now there we go with x square upon b square plus y square upon a square equal to 1. Center is 0, 0. Vertex will be 0 comma a and 0 comma minus a, because now in this case, if we are assuming that a is more than b, then ellipse is like this. This is x-axis and this is y-axis. This is your ellipse. Focus will be 0 comma c, 0 comma minus c. Major axis 2a, minor axis 2b. Equation of major axis is basically major axis is now y axis. So equation is x equal to 0. Minor axis y equal to 0. Eccentricity is under root of 1 minus b square upon a square. Got it? Length of latest rectum is 2b square upon a. Here it is 2a square upon b. Latest rectum, we have just talked about it in the parabola. Latest rectum is what? It is the chord passing through the focus and perpendicular to the axis of the conic. Auxiliary circle is x square plus y square upon a square is equal to a square. X square plus y square is b square. And directrix is x equals to plus minus a by e. Its directrix is x equals to plus minus b upon e. Understood? Now you must be thinking, what is auxiliary circle? So auxiliary circle is nothing but a circle drawn on major axis as diameter. Circle drawn on major axis as diameter is called auxiliary circle. So auxiliary circle is what? Circle drawn on major axis as diameter. Now, position of a point with respect to an ellipse. So if the ellipse is x square by a square plus y square by b square minus 1 equal to 0. So we check a quantity S1, that is x1 square upon a square minus y1 upon b square minus 1. So if this value, this is less than 0, then point x1, y1 lies inside. If this value equal to 0 on the conic, and if this value is greater than 0, then point lies outside. Got it? Now, condition of tangency. So line y equals to mx plus c touches the ellipse x square by a square plus y square by b square equal to 1 if, very important, c square is a square m square plus b square. Got it? So this line y equals to mx plus c, it touches the ellipse y equals to mx plus c, it touches the ellipse if c square is equals to a square m square plus b square. Got it? Now, point of contact is, if you can remember, it's fine. If you cannot remember, it's tough to remember basically. So if we are required to find the point of contact, we'll find it in a very short while. Got it? Now, equation of tangent in different forms. So again, tangent in point form can be obtained same, replacing x by x square by x1 and y square by y1. So equation of tangent at x1, y1 will be x1 upon a square plus y1 upon b square equals to 1. Now equation of tangent in the slope form m is y equals to mx plus minus under root of a square m square plus b square. So tangent in the slope form is mx plus minus under root a square m square plus b square. Now tangent in the parametric form a cos theta b sin theta is x cos theta upon a plus y sin theta upon b equals to 1. So tangent in the parametric form is x cos theta upon a plus y sin theta upon b equals to 1. Because on the ellipse x square upon a square plus y square upon b square equals to 1. Parametric point is a cos theta comma b sin theta. A cos theta comma b sin theta. Now normal at x1 y1, again I insist you not to remember it. It is a line perpendicular to the tangent. Simply, it is a line perpendicular to the tangent at the point of tangency. So you don't have to remember the equation of this normal. Again, equation of normal in slope form is not so easy to remember. So I recommend you not to remember this also. Yes, but equation of normal in parametric form is quite an important point. So you should remember it. This is ax sec theta minus by cos sec theta is a square minus b square. Got it? So equation of normal in parametric form is ax sec theta minus by cos sec theta is a square minus b square. Now again same thing, pair of tangents is ss1 equals to t square. Chord of contact is again t equal to 0, but make sure this point lies outside the conic ellipse. And chord with the given middle point is again the same thing, t equals to s1. So this is your t and this is your s1. So chord with the given middle point is t equals to s1. Now, director circle, again the director circle, locus of a point from which two perpendicular tangents can be drawn to the ellipse. Okay, let's do it. Let y equals to mx plus under root of a square m square plus b square is a tangent. It passes through h comma k. So make it pass through. So k minus mh is under root of a square m square plus b square. K minus mh is under root of a square m square plus b square. Now square both sides. Square both sides. So if you square both sides, you get k square plus m square h square minus 2k mh is a square m square plus b square. So it comes out to be m square into h square minus a square minus 2mhk plus k square minus b square equals to 0. Now its roots are m1 and m2. So if the roots are m1 and m2, then product of roots will be minus 1. So k square minus b square upon h square minus a square is equals to minus 1. So if you cross multiply it, you get h square plus k square is equals to a square plus b square. So director circle equation is x square plus y square is equals to a square plus b square. So make sure you remember this equation. For the ellipse x square by a square plus y square by b square equals to 1, its director circle is x square plus y square is equals to a square plus b square. Now let's see a question. Let L be the tangent line to the parabola. L is also a tangent line to the ellipse. Then find the value of B. Give it a try. Take 1 minute, give it a try. This is the poll for you. Just take a moment and mark your answer. Yes, others also give it a try. All right. Now let's do it. See, L be the tangent line to this parabola. Parabola is y square equals to 4x minus 20. Now tangent line at 6 comma 2. Is this parabola passing through 6 comma 2? Yes. So equation of tangent will be y1 2y equals to 4 times x plus 6 upon 2 minus 20. So y equals to x plus 6 minus 10. So y equals to x minus 4. This is the equation of tangent. Y equals to x minus 4. Now they are saying this line is also tangent to the ellipse. So condition of tangency is c square equals to a square m square plus b square. So c square, if I compare this y equal to mx plus c square will be 16, a square is 2, m square, m is 1 plus b square is simply b here. So what do I get b? B is what? 14. So this is your answer. All right. Now let's do another question. If the coordinates of 2 points A and B are this and this respectively, and P is any point on this conic, then PA plus PB is. See, we have done a focal distance property that PA plus PB is constant. But first, that A and B should be what? Focus. So first of all, let me check what is the focus here. So the ellipse is x square by 16 plus y square by 9 equals to 1. Eccentricity is under root 1 minus 9 over 16. That is root 7 by 4. So AE is what? A is 4, E is root 7 by 4, that is root 7. That means these F1 and F2, these are foci. So F1 is root 7 comma 0. F2 is minus root 7 comma 0. So PF1 plus PF2 comes what? Is 2A. Now, according to the ellipse, A square is given as 16. So A is 4. So 2A goes 8. So 2A is 8. Understood? So that is also a previous year question from 2021 J means. Now see, this is a very important portion, especially parabola and some sort of ellipse. Hyperbola is moreover, it is like ellipse. Its formulas correlate with the formulas of the ellipse. So if you are going with the conic section or you are going with coordinate geometry, make sure you have a complete hold on circle and parabola at least. If 100 questions are asked from this conic section, 50 questions are from circles only, 20 are from ellipse only. Oh, sorry, 20 are from parabola only. And then rest of the questions are from straight line, pair of straight line, ellipse and hyperbola. So this circle and parabola is majorly important. All right. So make sure you do it thoroughly, you do it by heart, and you do it multiple times to get through the entire idea. This is really, really important. And moreover, these conic sections and coordinate geometry, they are totally correlated. So if you are good with one, you are automatically good with the other portion. You see, equation of tangent is almost same everywhere and can be derived using a very simple substitution. Equation of chord of contact, same. Equation of chord with again middle point, same, T equal to S1. So things are so correlated. So if you are good with one chapter, you are good with others also. If you are not good with one chapter, you are not good with others also. So make sure whatever you do, starting with the circle, you do it with full proficiency so that your comfort zone increases with respect to time and with respect to the next chapters. All right. That would be all from my side today. And happy learning, happy studying. Wish you all a very, very happy new year. And make sure you do it again and again. Thank you. All right, students, that would be all. So now before ending, I will just ask you for a feedback of this